I believe that people wrongly fear studying science. Science is a branch of knowledge and the systematic study of the universe and all that encompasses, one that is based upon facts, observation, and experimentation. Some people love science and others less so. Maybe you are one of the individuals who thinks it's hard. Quite frankly, it should be hard. I'm sure you know that anything worthwhile in life is a difficult endeavor, but always worth fighting for. And, of course, you reap what you sow, and if you work hard at it, you gain far more than grains of knowledge and the gift of persistence that comes from toiling in the field of science. You gain a specific kind of mindset for the rest of your life, a mindset that allows you to logically observe and learn the truths of the world that are based on evidence and objective understanding. Such a mindset can open new and exciting worlds for you. Maybe you'd like to find out why Mentos makes pop fizz, or perhaps you want to find out how we can travel forward in time. Further still, you may want to cure someone of a disease and earn their undying gratitude. Science allows you to do all of this and more. From all of that, you should have understood that the nature of science is one that is based upon reason, experimentation, facts, and truths. Science aims for logic, ration, and objectivity, even in the face of a lot of unknowns, wild emotions, and the subjective whims of the mind trying to steer our fallible minds into traps of surreality. Science is not dogma, a set of principles laid out as being unquestionably true. Scientists have shown over and over again that as we search for the real answers in this world, truths can change all based on newer and better information. This is very disturbing to some, especially those that prefer a stable world in mind. It may help explain why some people prefer other avenues of so-called truths to answer life's questions, as these dogmatic answers are much simpler to understand, unchangeable, and less stressful to deal with. Imagine if we still believed in the historical dogma of the sun revolving around the earth. If that was still the case, your GPS wouldn't work, your TV wouldn't be able to entertain you, and you may even have trouble using your beloved smartphone. And that's just the tip of it all. But scientists love new information. That is their nature and that of science itself. New information yields better ideas, technology, and saves lives. Speaking of simple explanations for our world, science is also not the same thing as pseudoscience, something that astrology is the perfect embodiment of. Pseudoscience is a false or fake science, a system of beliefs that looks like it is based on scientific ideas, but actually doesn't employ or obey the simplest rules of science itself. A pseudoscientist is someone who pretends to use real science. Sort of like Frank Abagnale, the man behind the movie Catch Me If You Can, starring Leonardo DiCaprio, pretended to be all sorts of people and used all sorts of credible sounding terms to pass himself off as a lawyer or pilot. Take a story of pretending to be a doctor. A pseudoscientist is like someone who dresses like a doctor, throws around terms they barely understand left and right to sound credible, but when faced with a truly scientific scenario, like having to deal with a severely injured patient, they panic, don't know what to do, and wouldn't be able to justify their decision-making process with any significant modicum of logic. In short, real science is very specific, testable claims that are laid out and verified. If they are not verified, they are rejected. A sure sign of a pseudoscience is the disregard of contradictory evidence and alternative explanations. Pseudoscience is also a field which fails to have any real proof for its assertions, unless you consider a blurry picture of the Loch Ness Monster as proof of anything. Poor Nessie, it's never the camera's fault, she's just naturally blurry. As opposed to taking blurry photos, scientists study the world by coming up with new hypotheses, testing them, and then developing successful ideas into theories and laws. These theories and laws tell us how the world really works. A hypothesis is a single assertion, a proposed explanation of something based on available knowledge for something yet to be explained, and that is subject to further experimentation. A theory is a system of assumptions that generalize results of well-confirmed hypotheses in order to apply them to a wide range of circumstances. Let me differentiate the two for you in an example. Louis Pasteur, a French chemist and microbiologist, hypothesized and later proved that microorganisms were carried around through the air and as a result contaminated objects. While many others thought that this was the case, none were able to prove it until Pasteur did so. Once his hypothesis was confirmed, a theory came to fruition. It was the theory that some diseases develop when microorganisms are transmitted through the air, or otherwise, from one sick person to another. There is a humongous misconception that a theory is only a tentative guess. Yet theory is a word used by scientists to denote an idea that is very much well confirmed by plenty of evidence. It's anything but a guess. I'm sure you are well aware of the fact that germs can be passed from one person to another to cause disease. It's an accepted fact. Yet this thought is still called the germ theory of disease. A theory shouldn't be confused with natural law, however. A theory that is so well confirmed, refined, and tested as to be virtually universally accepted becomes natural law. Science is a branch of knowledge and the systematic study of the universe and all it encompasses that is based upon facts, observation, and experimentation. Science is not dogma, a set of principles laid out as being unquestionably true. And science should not be mistaken for pseudoscience, which is a false or fake science or system of beliefs that looks like it's based on scientific ideas, but actually doesn't employ or obey the simplest rules of science itself. Scientists use hypotheses, theories, and laws to explain our world. A hypothesis is a single assertion, a proposed explanation of something based on available knowledge for something yet to be explained that is subject to further experimentation. A theory is a system of assumptions that generalize results of well-confirmed hypotheses in order to apply them to a wide range of circumstances. A theory that is so well confirmed, refined, and tested as to be virtually universally accepted becomes natural law.